Hi there! In a previous video we looked at one-dimensional arrays, and this video will now follow that by looking briefly at two-dimensional arrays. You'll remember from the previous video that when we declare a single integer variable, we use the data type followed by the name of the variable. To assign a value to that variable, we simply then use the name of the variable equals whatever value we're trying to put in there. In this particular example I've used integers, but don't forget we can have variables of any different data type. To date we've looked at integers, doubles, strings and characters. So we can in fact have an array of integers, doubles, strings or characters either. The one-dimensional array of integers then, when we declare it, we use the data type, the name of the array, and then very importantly we use the square brackets to denote that it's going to be an array. The next step then is to create the array, where we must also then put the size of the array in the square brackets. Remember the difference now between the size of the array and the last index of the array. So you'll see here in this example the last index of this array is 3, but the size in fact is 4. That's how many spaces are there in the array. Here then we're assigning the value 7 to index 0 in the array called results. So you'll see the 7 goes in here. Then we assign the value 9 to index 2 in the results array, so the 9 goes in here. Following on from that then, this is just an array with one single row of data. But we can in fact, and sometimes we need to, we can in fact have a two-dimensional array of integers, whereby we can have more than one row in our table. In this instance, to denote that it's a two-dimensional array, we use two square brackets when we declare it. I've just called this array R. And then when we create the array, we have to put the size in both of the square brackets. The first square brackets, in this instance 2, denotes how many rows we're going to have, and the second square brackets denote how many columns are going to be in each row. This is really important to remember, and it's something students often get wrong. So it's rows followed by columns. 2 rows, 3 columns. You'll see then that the rows are indexed 0 and 1 and would continue on if there were more rows, and then the columns are indexed 0, 1, 2. And again, that would continue if there were more columns. So again, the difference between the size and the last index in the array. It works much the same way as strings do. Then when I want to put 7 into index 0, 0 in the array, I say R 0, 0 equals 7. And that puts my 7 in here. The other number I've added here is R 1, 2 equals 9, and that puts my 9 in here. So remember, the first set of square brackets are your rows and the second set of square brackets is your columns. Okay? Similarly, you'll remember when we looked at one-dimensional arrays, we can in fact declare, create and assign the values all in one line of code, but only in the instance where we know exactly what values we want to put into the array. For example, here I've declared an array of integers called results, and I've assigned the values 1, 2, 3 and 4 by simply putting them in curly brackets separated by commas. In the same way that we do that, we can also assign the values for a two-dimensional array. So int R is the name of my array, 2 sets of square brackets. This time in my curly brackets I have a subset 1, 2, 3, which denotes the first row in its own set of curly brackets. Then there's a comma, and then we have 4, 5, 6, which is my second row in its own set of curly brackets again. So again, if we know what values we want to put into the array to start with, we can indeed assign them this way. The best way to understand this, I think, will be by looking at a coded example. So let's pop straight into TextPad, where I've prepared a Java file here called two-dimensional arrays. I've got my class header and I've got my main method header, and literally we are just going to look at, first off, initializing all elements of a two-dimensional array to 0, and then we're going to take a look at printing the contents of a two-dimensional array.
Now obviously, when we look at initializing all the elements of a two-dimensional array to 0, okay, I'll just declare my array, declare and create my array up here. So again, we'll take the example we were working with, int r, 2 sets of square brackets. That's to declare it. R equals new int, and the size goes in my square brackets. So again, we'll do 2 and 3, 2 rows, 3 columns. Now I could then say r 0, 0 equals 0, r 0, 1 equals 0, r 0, 2 equals 0, and then go on to r 1, 0 equals 0, and so on and so forth. But you can see I'm repeating myself over and over again to do the same thing. I'm assigning a value, the value of 0 in each instance. So when we find ourselves repeating ourselves, the best thing to use is in fact a loop. So in the case of a two-dimensional array, we use one loop with the iterator I, okay, we use the counter I to count how many rows we're going to have, and then inside of that loop we use another loop to count how many columns we have. So in this instance it's int I equals 0 because that's the first index of my array. I is less than, now in this case I know I've got 2 rows, so we'll pop 2 in there for now. I equals I plus 1. Inside that, for int, now I can't use I again because my I from my outer loop is still active, so we'll jump to j because that's the next letter in the alphabet. Int j equals 0, j is less than, and again in this case I know I have 3 columns. J equals j plus 1. Okay, and then inside that I simply say r I j equals 0. And what this will do is it will loop through each space in the array, assigning a 0 to that particular space. First time round, I has a value of 0, j has a value of 0, and we put the 0 in. Second time round, I is still 0, but j is 1, so we put in a 0. Third time round, I is 0, j is 2, so we put in a 0. Then we've reached 3, so we jump out of the j loop, back up to I, increase I becomes 1, and j gets reset to 0, and we go again for our second row. So, like I said, we were able to use 2 and 3 here because we know in this particular example that's the size of our array. You might find in other examples that the user has determined the size of the array somehow. So it's important to know how we can calculate that. You'll remember from the one-dimensional arrays that we're able to do r dot length. Okay, and if we say I less than r dot length, that will ensure that it doesn't go over the 2. The trickier part then is inside that, and what we want to say is r 0 dot length. So we're saying in a particular row of the array, and again remember we don't actually need the brackets here, not for arrays. In a particular row of the array we want the length of that, so that's going to give us our 3. So this r0 dot length gets us the length of a particular row in the array, whereas r dot length gets us the number of rows that we have. Following on from that then, just to be sure that we know our zeros have all been assigned, we should then loop through the array to print the contents. So again, our array is going to look exactly the same. Int I equals 0, I less than r dot length, I equals I plus 1. Inside that, for int j equals 0, j less than r I or r0 dot length, j equals j plus 1. And then in here we simply say system.out.println r I j. and close our brackets for our for loop, our brackets for our main method, and our bracket for our class. Now in this instance what's going to happen is it's going to print each element of the array on a new line. If we wanted to print out in table format, similar to how we had it in our example on the slides, what we should do is system.out.print rij, and for each iteration of the j loop then, every time it finishes, we should do another system.out.print ln with nothing in it. Okay, so let's just compile that and see have we any errors. No, and let's run it then. So we get 0, 0, 0, 0, 0, 0, like our table. We've assigned all of our zeros to our array and it prints out perfectly. So that's two-dimensional arrays in a nutshell. It's very important that you know how to traverse an array, a two-dimensional array, using a nested loop. So when we have one loop inside the other, it's known as a nested loop. This one is nested inside of the other one. So it's important that you know how to declare a two-dimensional array, create a two-dimensional array, assign values to it, and that you know how to loop through it, either to assign initialize values, to print the contents, or in fact to sum up the total of all the elements in the array, which would then also allow you to calculate the average of the array. So all of those sort of things. So just a reminder then, the key things for your two-dimensional arrays are your double square brackets, and to remember it's rows followed by columns. Best of luck, thank you.